Our first step is to figure out what our delta x is. That's our b minus a over n. So we'll have 4 minus 1 over our n. And remember, we're doing this for a generic n, so it's just going to be equal to 3 over m as our delta x. All right, then we go over and find our endpoint. I like to use the right endpoint just because it does tend to be a little easier to work with computationally. So plugging into the formula, we have our a in this case is equal to 1. Plus I is our index, it stays as I, and then my delta x, I'm going to plug in 3 over m. So that tells us that our CI is 1 plus 3i over n. So once we have our delta x and our CI, then we can go into our definition of the definite integral. So we will have that the integral from 1 to 4 of f of x, which in this case is 5x dx, is equal to the limit as n goes to infinity of delta x times the summation from I is equal to 1 to n of f of ci. And you could keep this delta x inside the summation, but here's the reality of the matter: every single time, because we're dealing with a regular partition, the delta x can come out in front of the summation. So I just kind of memorize it as delta x times that summation. All right, so now we want to plug in on the right-hand side our delta x and our CI. So this will become the limit as n goes to infinity. Delta x is going to be 3 over m. Summation from I is equal to 1 to m. Now, to find our f of CI, we go over here and use the fact that f of x is 5x. So f of CI, if you look at what your CI is, it's this f of 1 plus 3i over n. So what you will do is you will replace all of your x's with this 1 plus 3i over n. And let me scoot this up a little here. So you'll replace the x with the 1 plus 3i over n, and then over here you'll replace this x with the 1 plus 3i over n. So our f of 1 plus 3i over n, or f of CI, is going to get substituted in as 5 times 1 plus 3i over n. All right, now once you have everything plugged in, then the first step, and this goes back to this worksheet again, once you plug in your delta x, your CI, then you want to pull out your constants and split them up so that you get either CI, I squared, or I cubed inside of that summation. All right, so let's go over here and try to tackle that. So we are going to have the limit as n goes to infinity. This 3 over n has to stay to the right of this limit notation. Inside of the summation, we have a 5 that can get distributed. So we'll say 5 plus the 5 times 3 gives us 15i over n. All right, now you can, if you want to, you can put a parentheses here just to really emphasize all of that as our summation. Now, we want to split this up so it's constants and i's. So what we're going to do is we're going to write this as limit as n goes to infinity, 3 over m. And then inside this bracket, I'm going to split this up into 2 separate sums, which I can do because of that plus. So this is going to become the summation from I is equal to 1 to n of 5 plus, now this 15 over n does not depend on this index of I. So the 15 over n can come out in front of this second summation. And then we have I left over. All right, so that is using our sum rule, and then also the fact that we have a constant in the 15 over n. And remember that a constant is anything that is not I, the index in this case. All right, so now we have terms or summations of the form of a constant and I. So what we can do is we can now use our summation formulas. So here we're going to use our summation formulas. So this 5 is going to become a 5n, and that's by the summation formula. C is going to become Cn. And the summation of the i's, that is going to become n times n plus 1 over 2. Okay, and everything else is going to be the same. So this summation of the I is equal to 1 to n of 5 became 5n. This summation of the i's became n times n plus 1 over 2. But we still have the 15 over n plus, and we still have this whole limit as n goes to infinity of 3 over n. Okay, So we've applied our sum rules, we've gotten our sum out, and now we're going to focus on simplifying so that we can evaluate the limit. Now, when we simplify, what we want to do is we want to get it in the form of numbers and numbers over n to a power p, because that will help us to evaluate the limit. So let's go over here, just a quick switch, and think about this. So the first thing that oftentimes happens with the summation of the i's is that an n multiplied here and this n will cancel. So I always immediately do that. And then I say to myself, okay, there's really not too much to do after that. And then I start to distribute as much as I can or as much as I need to. So in this case, I would have 5n plus, if I distribute the 15, I would get 15n plus 15 over 2. Now, you can sit there and get a common denominator for what is inside of this bracket. However, it is not really necessary, because what you want is several little terms that are of the form a number or a number over n to a power p. So what I usually do after I distribute that parenthesis is then I'll distribute to all three terms. Remember that terms are separated by addition and subtraction. So you have three terms here. You have the 15n over 2 and the 15 over 2. So this will become the limit as n goes to infinity. The 3 times the 5 will give us 15n over n, plus 15 times 3 will give us 45n over 2n, because you're multiplying straight across, plus the 3 times the 15 gives us 45 over 2n. Now, if you simplify, you see that these n's cancel, so you have a 15. You see that these cancel here as well, and then you have 45 over 2n as your last term. All right, so evaluating this limit, what we are going to see, and this is our last step where we actually take our limit. Our limit of 15 is just 15. Our limit of 45 over 2 is just 45 over 2. The limit of the 45 over 2n, because this n is in the denominator, when n goes to infinity, it is going to blow up. It's not going to blow up, n is going to blow up, but this whole thing is going to go to 0. So because the denominator blows up, we will see that the whole second or last term here is going to go to 0. All right, so that's going to go to 0, and then we just need to combine the 15 and the 45 over 2 by getting a common denominator of 2 over 2. So that gives us 30 plus 45, so we get 75 over 2. And that is our evaluation of the definite integral. So again, I want to be very clear. All of this work, if you follow the equal sign up to the very, very beginning of this problem, what we are saying is we are saying that the integral from 1 to 4 of 5x dx equals, through this limit process, 75 over 2.